7 miles down. That's where the Mariana Trench reaches, the deepest point on Earth. A place where the pressure is so extreme it would crush a human instantly, where a single square inch of your body would feel the weight of 1,000 elephants. Total darkness, near freezing water, no oxygen, nothing to eat. Scientists once believed nothing could live there. They were wrong. There's a fish down there, pale, ghostly, thriving in conditions that should pulverize bone and collapse organs. This is the Mariana snailfish, and what it takes to survive at the bottom of the ocean will rewrite what you think is possible for life on Earth. For most of human history, the deep ocean was more mysterious than outer space. We'd been to the moon before we'd explored the deepest trenches. The technology didn't exist. The pressure was too great, the darkness too complete. In 1960, 2 men descended to the bottom of the Mariana Trench in a bath escape, a pressurized steel sphere, Jacques Piccard and Don Walsh. They looked out their tiny window into the abyss and saw something impossible. A flatfish swimming past their window 7 miles down. It shouldn't have been there. At that depth, nearly 36,000 feet, the pressure is over 15,000 pounds per square inch. That's more than 1,000 times the pressure at sea level. A human body would be crushed instantly. Lungs would collapse, bones would shatter, every air pocket in your body would implode. But that fish was fine. For decades, scientists debated what they'd seen. Some thought it was a hallucination. Others believed it was a fluke, a fish that had drifted down by accident and was dying. Then, in 2014, a team of researchers from the University of Washington sent a deep-sea camera to the Hadal Zone, the deepest region of the ocean, below 20,000 feet. At 26,722 feet, in the darkness of the Mariana Trench, their cameras captured something extraordinary. Dozens of fish, small, pale, translucent, swimming, feeding, thriving. They weren't struggling, they weren't dying, they were at home. Scientists had discovered the deepest living fish ever recorded, Pseudoliparis swirei, the Mariana snailfish, and it lives in a world that should be impossible. Let me put the Mariana Trench in perspective. If you dropped Mount Everest, the tallest mountain on Earth, into the Mariana Trench, the peak would still be over a mile underwater. The pressure at that depth is 16,000 pounds per square inch. Imagine every square inch of your body being crushed by the weight of 8 cars stacked on top of each other. At the surface, atmospheric pressure is 14.7 psi. Comfortable, normal. At 1,000 feet underwater, it's about 450 psi. Deep enough that human divers need special equipment and decompression stops. At 13,000 feet, it's 6,000 psi. Submarines with thick steel hulls start to creak and groan. At 26,000 feet, where the Mariana snailfish lives, it's 16,000 psi. Only the most advanced robotic submersibles can survive there, and even they risk being crushed. But this fish? It's soft, delicate looking, no armor, no thick scales, just pale, gelatinous flesh. It looks fragile, vulnerable, and yet it's one of the toughest organisms on the planet. The Mariana scalefish is about 4 inches long, translucent pinkish white, almost ghostly. It has tiny eyes. Vision is nearly useless in total darkness. Its body is loose, almost melting in appearance when brought to the surface. But down there, in its world, it's perfectly adapted. It feeds on tiny amphipods, shrimp-like creatures that scavenge the ocean floor. It swims slowly, efficiently, conserving energy in a place where food is scarce. And it does all of this while being subjected to pressure that would liquefy most life forms. How? The answer lies in biology so elegant it's almost unbelievable. Most fish have swim bladders, gas-filled sacs that help them control buoyancy. It's how they float, rise, and dive. But gas compresses under pressure. At extreme depths, a swim bladder would collapse like a crushed soda can. The Mariana snailfish has no swim bladder, no air pockets anywhere in its body, nothing to compress. Its skeleton is made of soft cartilage, not rigid bone. Cartilage is flexible. It bends under pressure instead of shattering. In fact, its skull is incomplete. There are gaps, spaces. It doesn't need a solid skull because there's no pressure differential. The water pressure outside its body equals the pressure inside. It's not fighting the ocean, it's equalizing with it. Think of it this way. If you tried to dive that deep, the air spaces in your body, your lungs, sinuses, ears, would collapse because they're at normal atmospheric pressure. You're essentially a balloon being crushed. But the snailfish has no air spaces. It's all fluid and soft tissue. The ocean presses on it from all sides, but there's nothing to collapse. It's like the difference between crushing an empty plastic bottle and crushing one filled with water. The empty bottle crumbles, the full one resists. But pressure isn't just about crushing, it affects chemistry. Molecules behave differently at extreme pressure. Proteins that keep our cells functioning would denature, unfold, and stop working under those conditions. So how does the snailfish keep its protein stable? Enter TMAO, trimethylamine N-oxide. It's a small organic molecule that the snailfish produces in massive quantities. TMAO acts like a biochemical pressure suit. It stabilizes proteins, preventing them from warping under extreme pressure. Shallow water fish have very little TMAO. Deep sea fish have more. And the Mariana snailfish, its cells are flooded with it. Scientists found that TMAO concentration increases with depth. It's a direct adaptation. The deeper you go, the more you need. But here's the catch. TMAO only works up to a certain depth. Around 27,000 feet, even TMAO can't protect proteins anymore. The pressure becomes too much. That's why the Mariana snailfish lives right at the edge, 26,000 to 27,000 feet. Any deeper, and even this miracle of adaptation would fail. It's living at the absolute limit of what vertebrate life can endure. You might wonder, why does this matter? Why should we care about a fish that lives 7 miles down in a place no human will ever visit? Because the Mariana snailfish is teaching us things we never knew about life itself. First, the limits of life. For decades, scientists thought there was a hard ceiling on how deep fish could live. Too much pressure and vertebrate biology would simply fail. The snailfish proved we were wrong. Life is more adaptable, more resilient than we imagined. If vertebrates can survive at the bottom of the ocean, what else might be possible? Could life exist in the subsurface oceans of Europa or Enceladus, moons of Jupiter and Saturn with liquid water beneath ice shells? The snailfish suggests maybe. Second, pressure biology. Understanding how TMAO protects proteins under extreme conditions has applications in medicine and biotechnology. What if we could use similar molecules to stabilize proteins in human cells, to preserve organs longer for transplant, to create drugs that remain effective under stress? The snailfish's biochemistry isn't just interesting, it's potentially revolutionary. Third, climate change insights. Deep sea creatures like the snailfish are incredibly sensitive to environmental changes. They've evolved over millions of years in stable, extreme conditions. As ocean temperatures rise and currents shift, these creatures are early warning systems. If the deep ocean changes, we'll see it in species like the snailfish first. But there's something else. Something philosophical. The Mariana Trench represents the last frontier on Earth. We've mapped the surface, we've climbed the highest peaks, we've crossed the poles. But the deep ocean? We've explored less than 5% of it. The snailfish lives in a world we've barely touched, a world of total darkness and crushing pressure, a world that feels more alien than Mars. And yet, it's here, on our planet, just a few miles away. It reminds us that Earth still holds mysteries, that there are places we don't fully understand, creatures we're only beginning to discover. The snailfish didn't evolve for us to study. It doesn't know it's record-breaking. It's just living, quietly, in the dark, surviving. And maybe that's the most profound thing of all. Not that they survive the impossible, but that to them, it's not impossible at all. It's just life. Life at the edge of what's possible. Life in the last place on Earth we expected to find it. The Mariana snailfish will never be famous. It will never leave its trench. It will live and die in darkness, 7 miles down, unknown to almost anyone. But it's there, proving that even in the most hostile place imaginable, life finds a way. Not by conquering, not by dominating, but by adapting, by becoming exactly what it needs to be. And maybe, just maybe, that's the ultimate form of strength.
If the idea of life thriving 7 miles underwater fascinates you, this channel is for you. We explore the creatures that break every rule, animals that freeze solid, bugs that survive 400 Gs, slugs that photosynthesize, microscopic bears that endure space. These aren't myths, they're real, and they're rewriting what we thought was possible. Subscribe so you don't miss what we uncover next, because Earth is full of impossible things, and we're just getting started. What extreme creature should I cover next? Let me know in the comment section below.